ಎಂಟು ಇದು ಬೇಕು ಎಂಥದ್ದು ಟೇಪ್ ಬೇಕು. Just 1 minute. Voice clear? Is the voice clear? Fast. Fully audible? Fully audible? Display and voice both. I made screen little smaller because here adjustment problem. Why? No reply. Clear or not? No reply came. Is voice clear or not? Okay. I don't know, usually people are absent. I will continue. It looks like you are a newcomer. If you are a newcomer, you should go to last class, understand and come back here. Because I cannot take anything for your sake. Okay. Now, see. Yesterday's question, I put one more light on. Little dark it is. 1 minute. It is not dark, it is little lesser light. 1 minute. Now little more bright, I think. Okay. See, this is a beam cross section we considered. We already considered bending stress diagram. See, bending stress diagram across the cross section. I won't keep on repeating this one. All values are in Newton per mm square. All dimensions here are in millimeter. And this everything is explained so far. Now, this bending stress is actually acting perpendicular to the cross section. This I am repeatedly telling right from beginning. Now, see, because of the stress, upper flange will have compression. Why means, see last class, sagging beam. This portion of web which is below the flange, above neutral axis, that also is in compression. And the web portion which is below neutral axis up to here is also, it is in tension. See, I have shown arrow mark this way. And this bottom flange is in tension. I don't remember what symbol I have given. Last time I got all the values. Okay. Now, I'll just do one thing. I will enter the values which is given last time. See, I will enter the values. I think I given C1 dash, C2 dash, and here T1 dash, T2 dash. C1 dash, C2 dash. This is C1 dash is compression force in the, see, C1 dash, compression force in the upper flange. C2 dash, compression force in this portion. Then T1 dash, I think T1 or T2, which one? Okay, that's correct. T1 dash, tension force in the bottom flange. Here. T2 dash, T2 dash is tension force in the web below. These all values you got. Also we got last time where this force acts. See, this is acting from here through CG of the trapezium. See the stress diagram. CG of the trapezium. This will act through CG of the triangle. This will act through, once again, CG of this triangle. This last force, T1 dash, will act through CG of the trapezium. Everywhere, force equal to average stress into area. All of them were thoroughly explained last time, so no repetition. So if I enter the values, I have to see the last time class. See, C1 dash is 247.3524 10 to the power 3 Newton. C2 dash is, I am seeing, see, I am not seeing a paper, written paper. I am seeing the display of the last class. Means this is already over last class. Last class display I am seeing. C2 dash 93.8246 10 to the power 3 Newton. Then T1 dash is 290.72 10 to the power 3 Newton. T2 dash equal to 50.4477 10 to the power 3 Newton. Remember, I told you, in this course, I am giving too much importance to basic knowledge, not exam-oriented questions, not academic point of view. To learn the subject thoroughly, what all knowledge you require, that I am giving. So, it is purely technical oriented, not academic oriented. But little later, when I cover more questions, it is equally helpful academically. Okay, that you have to use it. But the very name of the course, you have those who are seeing on YouTube, majority are what? They are seeing because I have made it public in YouTube. Original course is BSK, Basic Structural Knowledge. Class number today 124, means more than 100 classes are uploaded there earlier. That is not visible to general public. It is only for the people who are in the group. This particular portion, which one? Bending stress and shear stress, I decided to give public information. Okay, now this distance we got 9.8777 millimeter. See, 9.8777 millimeter. Why? Through CG of this trapezium. See, this is 20. CG will be slightly away from center, that side. So midpoint is 10, slightly lesser. And C2 dash, it is for this much portion. Its center of gravity for this triangle from here is 1/3 of that length. That is 87.5033. 87.5033 millimeter. Okay, then T1 dash is through CG of this trapezium. The depth is 25. Center will be at 12.5. Because more stress is there, CG will slightly shift down. It will come less than 12.5. It came, where is the answer? Yes, 12 point, not 1 point. Okay, 1 minute. It came 12.2459 millimeter. And this T2 dash distance is, it is through center of gravity of this triangle, 1/3 from here. That is, where is the answer? 64.1633 millimeter. Okay. These are the forces normal to cross section because of bending. See, forces normal to cross section due to bending. Force equal to average stress into area. General language, force equal to stress into area. If stress is uniform, if stress is varying, force equal to average stress into area of the cross section normal to which the stress is acting. These all told earlier. First of all, I need not tell. Okay, now I don't have to see the last class answer. Okay, now tell me, what is the bending moment for the cross section? Anybody can tell? Anybody can tell what was that bending moment for cross section? Just for information, M. How much? Tell me. Okay, I see a YouTube. I'll go to chat section now. Tell me, what is the bending moment for the cross section? First, yesterday I considered it. What was the bending moment for the cross section? First answer. If nobody gives the answer, I will stop the class. I always do that way. In some way, I am very strict. If there is no response, I will stop the class. Then next time, I will not continue this one. This is gone for you. Means I will tell you don't deserve to learn from me. I will tell that only. No, don't deserve to learn from me. Tell, what is the, I will wait for some time. If answer is not coming, that is if all are newcomers, if you don't answer the question, nothing can be done. I will first check voice audible. Yes, fully audible. Nobody can tell not audible. See, no answer. What you should have noted down those values. I told when you attend the class, what are important values? Like I may ask suddenly, what is the moment of inertia of this cross section about neutral axis? I may ask you once again, if requirement is there. If I ask what is the moment of inertia, answer should come immediately. You should not tell it is in the old class. I understood. No. Those who are studying from me, they should make a note. In a paper, they should write these values. Full details notes they can prepare later. Tell me, what is the bending moment for the cross section? I will not wait more than some time now. See, I always feel people who come for learning from me, they should behave disciplined way. The random way, lazy way, half sleeping, that way, students, I do not want. I always tell, whatever I tell, in case it is not clear for them, I will tell they are not fit for education. See, little arrogant word, I know it. It is little arrogant. Someone telling, if you don't understand from me, you are not fit for education. Yes, I know my capacity. Tell me, what is the bending moment for the cross section? I will wait for some time and then suddenly stop the class and then further I will not continue this question. Let it be hanging only. Tomorrow somebody will request, so that question is not clear. What is the principle I am going to tell today? How the bending moment is resisted by cross section. For that I want the bending moment for the cross section. 150 answer came. If you are not given the answer now, another 2 minutes I would have stopped the class and then permanently not continue this question. You stand to lose. I don't stand to lose, because I will not lose. Why? How can I lose? You stand to lose. Okay. 150. Okay. Finally answer came. After asking so much. It is 150 kilonewton meter. And also remember, it is sagging beam. Okay. Now, correctly understand, even those who are seeing recording later, this is the time for you to understand analogy between RCC and structural part. There are some interesting questions I will ask you as soon as I finish this one. No, so far, not a single person could give the answer to me. Everybody failed. So many people, I asked the question. Nobody can, even people they call intelligent, they know too much. I saw that one. Not a single person can give the answer to this one. Okay, let me see whether you can give or not. Okay, now start. Now, see, this sketch I am removing now. I do not want this sketch. Now, what you want is, see, this cross section, I will tell last time for you, is subjected to a compression here, a tension here, and a tension here. See, all these arrow marks are perpendicular to the cross section. Perpendicular to the cross section means, if you see lengthwise, you can see the forces like this. Perpendicular to cross section. See, if I write cross section, it is perpendicular. Whereas, if I put the beam lengthwise, see, lengthwise this way, then they are acting how? This way and this way. Clear? Tell part. Those two compressions are acting like this and like this. These two tensions are acting like this and like this. Bending stress is always perpendicular to the cross section, and bending stress is always along the length of the beam. Remember, they are along the length of the beam. But when you take cross section, it is perpendicular. Just tell me, clear or not? Clear? It is always along the length of the beam. First tell me, clear. You should tell clear. I am asking question for two reasons. One reason, I want people to tell clear. Second, if any problem is there, like audio problem or video problem, I can make out. Okay, now, see what I will do. This cross section I am removing now. See, I am removing cross section. Today's class, remember, is fully technical knowledge oriented. Okay, now, what I will do is, I will write the beam. See, the beam is like this. Maybe it is possible that one side support is there. Okay, no problem. Subjected to pure bending. Means what? If I see here, see, pure bending is only bending moment M, this way, M. This is, see, the bending moment is this way. If the bending moment is that way, you need a balancing moment this way. Anybody can tell. See, in case I turn this way to prevent bending equilibrium, you have turned this way. Correct? If I turn this way, you also turn that way, everybody will fall down.
Overheating.
Mamulu. That's okay. So, see, for this one, see, the balancing moment should be like this. See, I will call this as M dash. M dash. So, this M dash I will call reacting moment. Reacting internal, or I will call you, it is internal reacting moment. Internal reacting moment. How? developed by cross section and which will balance external bending moment M, external bending moment equal to M. Therefore 100% your M dash should be equal to how much? Tell me. 100% M dash should be equal to, fast, your M dash should be equal to 100%. This M dash should be equal to, fast, tell me symbol. See, action and reaction. You give somebody 100 rupees. Why? Reason? Because maybe 2 days earlier he gave you 100 rupees. No interest here. See, some will tell, sir, what about interest? Interest is not counted here. See, therefore, suppose you pay somebody 100 rupees, may be possible that not possible. He has given you either 100 rupees or some item worth 100 rupees. See, when you go to a shop, you give 100 rupees there. Means he has given you some items worth 100 rupees. Okay, now, should be equal to M. So, our question, this M dash value should come, how much? Tell me. Our question, this M dash value should come, how much? Numerically. For our class question, this M dash should come numerically, how much? 150 kilonewton meter. Remember, 150 kilonewton meter. Answer. See, this is the most dangerous thing to do in a class. Somebody who takes a class, announcing the answer before solving is the most dangerous thing. Suppose answer is not tallying, I will lose my face. I will become a laughing matter. People will tell that person told so many things, later answer did not come. I will lose my face, lose my credibility. Okay, I am ready to face that risk. My students will tell, sir, no risk, sir. Why? Sir, how it is possible that answer will not come? So, I have got guarantee that 100% it will come equal to 150. Okay, now, do one thing. Now, I will remove this sketch now. See, I will remove this sketch, put one more sketch here. See. Now, what I will do is, see, I will take the beam here, maybe for some length. Okay, stop. This is the cross section. Here support is not required. Here bending moment is M. That side, see, one force acts here. One more force acts here. Another force acts here. Another force acts here. Now, this is your C1 dash, this is C2 dash, this is T1 dash, this is T2 dash. Okay, now, what, this all I will remove now. What you should do is, see, if there is a force C1 dash here, C2 dash, it will have a resultant force here. Resultant for these two, I will use red color. Okay, I will use red color for the resultant. C, no 1, 2, C over. Here, resultant is T. Remember, this is you require for RCC concept. In the RCC, when you derive equation for bending, this is the principle used. Okay, now, between them, there is a distance called A. Anybody can tell, see, now, for equilibrium, your C should be equal to T. Remember, in RCC, 0.36 FCK into BXU equal to 0.87 F point AST, all are this one only. CU equal to TU. The C should be equal to T. Then C and T will give a force system. What will give? What will give a parallel force system? Parallel force system, which is what? Two equal, unlike parallel forces. Parallel forces. Okay, now you should write immediately. Two equal, unlike parallel forces separated by a distance will form what? Tell me. Will form a what? First, two equal unlike parallel forces separated by a distance, because if both are axial, no, will form a. Two equal unlike parallel forces will form a. This you are supposed to know. If you are not knowing, go back to engineering mechanics, study and come back, or other way, believe me. That's all. Ah, yes, couple, good. Someone should tell, will form a couple. Couple. Say that couple I am calling M dash. M dash. A couple which is called, which here is called internal resisting moment. Resisting moment. And for equilibrium should be equal to external bending moment M. This already told 10 times now. Over. Now start. This I am not removing for some reason. See, that I am not removing. Okay, this I will remove now. So now you have got two guaranteed results required. One, C should be equal to T. If that fails, my teaching will stop once for all there only. Second one, the moment of the couple for due to C and T should be equal to M. And also note, moment of the couple equal to either C into A or T into A. Now you should tell what is this A is called. First, distance between the lines of action of resultant compression force and resultant tension force on the cross section when the internal resisting couple is formed. That distance is called name. You should know it in RCC. That distance is called lever arm. Oh, parvailla. Someone is telling fluent answer. Okay, good. If you give correct answer, I am happy only. It is called lever arm. So, lever arm is the distance between lines of action of resultant compression force and resultant tension force on the cross section. Both forces are normal to cross section. This theory we are using repeatedly in RCC, steel, pre-test concrete, in so many subjects. Okay, start. So, this lever arm A. Okay, now, I will remove this one now. Now see, I should get C equal to T, condition number 1. And C into A or T into A, M dash, I have to get 150 kilonewton meter. Tell me, do you think I will get both or not? What do you think? Do you think will I get both or fail? What do you feel? Will both the values will both those will be satisfied in the class, or chance of failure? What do you feel? Just I am asking. Just to know whether you believe me or not. It will come. It will 100% come. Okay, start now. Now see, one by one. This all I will remove. See, understanding concept. Of course, I am telling very, very slowly. Some people will tell, he tells so slowly, tell same thing again and again. My answer to them, you come in front of me and face my questions. Can you answer? No. Then whatever I tell, listen. Do not comment on the type of teaching. You tell me, are you understanding or not? I am understanding easily. That's what is my class meant for. Okay, start. Now, result, red color I will not write now. Resultant C will be equal to C1 dash plus C2 dash. Tell fast answer. Tell the answer. Add those two. Tell the answer in 10 to the power 3 Newton. Fast. Add C1 dash and C2 dash. You should add. If you cannot add, why come to my class? Some will tell, he is not writing. Yes, why should I write? When C1 dash is here, C2 dash here, you got a calculator, add those two and tell the answer. Fast, fast. Add those two and tell me the answer. Little fast, don't waste time. Add C1 dash and C2 dash, 341.1766. 341.1766 kilonewton. Now tell me, what is the T value? The T value equal to T1 dash plus T2 dash. Add those two also, tell the answer in 10 to the power 3 Newton. Fast answer. Add T1 dash, add T2 dash, tell that answer also in 10 to the power 3 Newton. Answer. Kilonewton later. Kilonewton I'll write later, no problem. Fast, add it. Fast add. You are wasting time. This much time is 341.1749. Okay. 347.1749. Okay. Now you can see slight difference in the answer. Anybody can tell me why this? Don't give wrong values. Tell me 341.1766, 347.1749. Slight difference came. Tell the reason for the difference. First, what is the reason for difference? Reason for the minute changes. 340. No. What is the reason for slight alteration? Okay, 340. Oh, you 347 is dead. Okay. Print mistake. If I make a mistake, it is print mistake. Tell me. Okay. Print mistake. What is the reason for such a small difference? Reason you should know. If somebody tells me, sir, you got 1766 there, 1749 there, I will tell him, you write 1000 digits and write. Sir, that is not possible. Then keep quiet and listen to me. That's all. That is because of rounding off error. See, when you took this force, what? Average stress into area, we are rounding off to decimals. So, or remember, this error is how much? 0.00 around 3, 5, 16, 0.0016 in 10 to the power 6. 0.0016 in 10 to the power 6 is what? 1, 2, 3, 4, 5, 6. 1600 rupees. See, 1600 rupees is the difference in 341 10 to the power 3. 10 to the power 3, sorry, it is 10 to the power 3. So, it is 1, 2, 3. 1.6 rupees. It is 1 rupee 60 paisa or almost say 2 rupees. Okay, 2 rupees difference in 341 10 to the power 3. 1, 2, 3. 5,41,000. So suppose there is a transaction of around 5.5 lakh, 5,50,000 rupees. You have to pay somebody 5,50,000 rupees. When you are making payment of 5,50,000 rupees, suppose you tell, sorry, I have 2 rupees shortage. Tell what he will tell? What he will tell? He may laugh. People listening will laugh. 2 rupees he is talking for 5,50,000 rupees. So, in 5,50,000 rupees, 2 rupee difference. Tell me, is it a difference? Will you tell him, okay, 2 rupees you transfer to my account? Will you tell him? He will pay 5,49,998 rupees he pays and tells you 2 rupees shortage is there. So what to do? So you tell him, for 2 rupees, I will give my account number, transfer to my account. You tell me, whether you will tell that way. To be honest, whether you will tell. If somebody tells, you know name for him. What is the name? In local language, we call height of conjuice people. No, nobody in the right mind will claim 2 rupee difference. Okay, therefore, both are same. You write here, both are same within the marginal rounding of error. Therefore, I told you C and T should be equal is satisfied. Okay, now, once you satisfy that one, now come to the most critical part, The trump card or what? This is simple. That is complicated one. Balancing moment should come 150. I hope it will come. Start. Now, I want to know where is this resultant compression acts from the topmost edge. I want where resultant tension acts from the bottommost edge. I will call this as Y bar, Y1 bar. I will call this as Y, no, not Y1 bar, some other name. Okay, no problem. Y1 bar. This Y bar is not that Y bar. This I will call Y2 bar. I will call this as Y1 bar, Y2 bar. Now, I will write the answer here. C equal to T. C we got 341.1766. T you got 341.1749. Both are 10 to the power 3 Newton. Okay. Now, I want to know what is Y1 bar. Bar means not that bar. You are going after evening, not that bar. Y1 bar and Y2 bar. See, I will remove these two. These two I will remove now. Start. To get Y1 bar and Y2 bar, see, Y1 bar I will calculate. Y2 bar you should calculate and tell me the answer. At that time, I will take 2 minutes break for non-stop talking. Y1 bar I will calculate and tell the answer. Y2 bar you should calculate. Somebody may comment, he has done one calculation, other he has not done. If you are learning from me, what I tell, follow it. Okay, start. I will get Y1 bar. Y1 bar. See, from the top edge, see, this is the top edge. Top edge. From the top edge, see, the top edge of the beam is here. There. One force is acting here. That is your C1 dash. Second force is acting here. That is C2 dash. Okay. This distance is, see here, 9.8777 millimeter. Tell me fast, what is this distance? Fast. I want to refer from top edge. See, in RCC, it is x by 3 for working stress method and 0.42 XU for limit state method. If you know RCC, see, some will tell, sir, yes sir, same thing you do RCC. Yes, that is why I am doing this one. For those who want to learn the basic concept of structural engineering, for their sake I am doing it. Tell me this answer. Remember now, 87.5033 is from here. Tell me, what is the distance from top edge up to here? Tell me, this distance how much? Fast. Fast. This is C2 dash is 87.5033 from here. This is the upper flange. From the top edge how much? Fast, fast. From the top edge how much? Fast answer. Don't waste time. You know the sketches with you. See, from the junction of the flange, it is 87.5033. Therefore, from the top edge, how much is this distance? This much time you require. This much time you require to give that value. I will stop the class. See, same thing. I will stop the class. If this way answer is not given, I will stop the class. Yes, sometime I should be very harsh. If I stop now, second time, this concept I will not tell. You permanently stand to lose it. You will lose it. You will regret later. Some important concept is covered. Because of our irresponsible participation, we are losing. Abba. Finally, answer came. 97. What is this? Where is this? How you got 97? Tell me. I am asking you from the junction of the flange and web down by 87. Tell me, what is thickness of the top flange? What is, see, this is called irresponsible answer. What is thickness of the top flange? See the force diagram earlier. See the sketches given earlier. 20. If the distance from here to here is 20, if it is 87.5033, how much from here to here? Somebody who is watching the class later will get frustrated. He will tell, such a simple thing, he is wasting time. Then I will tell him, if you feel wasting time, come live and give the answer. If you feel I am slowing it down, come live and give the answer. Otherwise, don't comment, keep quiet. Learn from me or leave the class. I am always like that only. Then how you told 97? Tell me. How you told 97 first of all? I want reason. From here to some place is 20 kilometers. From there 90 kilometers. From here to the other place is how much? 110 kilometers. How you told, first of all, how you told 97? There should be a reason for it. For telling 97, what? Made a mistake? Absent-mindedness or didn't observe properly? Okay. It is 107.5033. See, it is 107. See there. See my capacity. I told the number there. When I came to the board, I forgot the number. I am so weak in remembering. That is, by-hearting is ruled out. I told I am weak in remembering or by-hearting, not in technical matter. 107.5033. 5033 millimeter. Okay. Now, see. Because of these two, see, correct, clear. Resultant force will pass somewhere here. This is resultant C equal to 341.1766 10 to the power 3 Newton. These C1 dash, C2 dash are here. It is here. Okay. Now, this distance is called our Y1 bar. Y1 bar. Now, use a theorem. Tell me, have you heard a theorem? If you want to locate the line of action of resultant, there is a theorem. As per the theorem, algebraic sum of moment of the given force system about any point is equal to moment of the resultant about the same point. Those who want, write it. Algebraic sum of moments of the given force system about any point is equal to moment of resultant about the same point. Can you tell me what is the name of this theorem? Oh, thank you. Yaru? Nandakumari H. Oh, suddenly appeared today? Yes, correct. Thank you. I was not knowing. I today came to know it by Nandakumar. Very thank you. Okay. It is called Weyrich-Knox theorem. Thank you. Courtesy. It is called Weyrich-Knox theorem. Weyrich-Knox theorem. So, apply Weyrich-Knox theorem. Take moment about the top edge. Then see, this will produce clockwise. This also will produce clockwise. This also produces clockwise. Therefore, sign convention not required. See, start. Moment about this point will give you C1 dash into C1 dash into 9.8777 plus C2 dash into 107.5033 equal to resultant for C into Y1 bar. C1 dash is known for you. 247.3524 10 to the power 3. C2 dash is 93.8246 10 to the power 3 and C resultant is 341.1766. Using this data, tell me what is your Y1 bar. Fast answer. Tell me what is Y1 bar. So Y1 bar, the red color is not working. I will put blue color. Okay. Red color is not working. Why not working? Ink problem. Okay, don't bother about it. Okay. y1 bar, okay, partially working. y1 bar, that is distance from top edge to line of action of resultant compression force on cross section. This is y1 bar. Give me accuracy of 4 decimal. It will come in millimeter. Fast answer. Correctly. One small mistake if you make, finally you will have problem. Answer. One small mistake if you make, it will have problem. Little fast. Why this much delay? Tell correctly answer up to 4 decimal. When you tell after up to 4 decimal, you should see the 5th decimal. And if it is 5 and more than 5, you should increase this number. If it is 4 or lesser, delete it. Okay. 72.36.72499 is 36.7250. Okay, thank you. 36.7250. 36.7250. That means it is this distance. So I will enter here this y1 bar equal to 36. I would later. This is y1 bar over. Now, same way, I will take a small break now. You should not take break. I will tell you what to do now. You should not take break. You should go other side now. See, you should go other side. Consider the bottom edge. Bottom edge. Sorry. Bottom edge is here. One force is this way. What is that one? T1 dash. One force is here. T2 dash. This distance is known for you. How much? 12.2549 millimeter. And tell me what is this distance? Be careful. From the junction of the flange and web, it is 64.1633. Tell me what is the thickness of the, see, it is not projected here. Actually, this level is this level. Okay. I by chance reduced it here. I am not projecting. From the junction of, what is the thickness of the bottom flange? Fast. Thickness of the bottom flange. Answer. What is the thickness of the bottom flange? Fast. Thickness of the bottom flange. 25 millimeter. If that is 25 millimeter, your T2 dash from bottom edge will be 25 plus another 64.1633. Tell the answer. 25 plus 64.1633. Answer. 20, same as upper side, no change. 25 plus 64.1633. 89.1633. Okay. It is 89.1633 millimeter. Okay. Now, what I have done there, you have to repeat here. See, once again. And resultant for these two will be somewhere here. T at y bar from here. y2 bar from here. So, apply Varigno's theorem right here. See, what you are right here? See, T1 in T1 dash into 12.349, T2 dash into 89.1633 will be equal to resultant T. Resultant T is here. Where is it? Resultant T. Where I wrote? Resultant T, I told you. Your resultant T equal to, we already got, what is the answer? 3, I rubbed it out now. 341 point, slight 2 rupees error came in 6 lakh rupees transaction. Right, whatever you got. 341.1749 10 to the power 3 Newton equal to resultant T into y2 bar. Tell me correctly what is y2 bar. It is your problem. y2 bar is your problem. So I will write here, therefore y2 bar that equal to, I want answer now. I want answer for y2 bar. That is what? This distance of distance from where? From bottom edge to line of action of resultant tension force. Correctly tell me this value also, full accurate, 4 decimal accuracy. Tell me the answer. I will take some 3-4 minutes break for non-stop talking for 1 hour. See, this type of only talking gives some strain. You correctly calculate and to type the answer. Or if the answer comes, you also take 3-4 minutes break. Go to Facebook or WhatsApp and enjoy and spend your data. Okay, now just 3-4 minutes or maximum 5 minutes. Today I am going to conclude everything, including RCC part also. Okay, just 5 minutes. Okay, start. Where is the mic? Here. Tell the value. How much? Y2 bar. Searching for that color pen. Okay, answer. Y2 bar. 23.62. See, one person is giving 23.6226. Other is giving 23.6193. This type of error should not happen in my class because this class has got value. Such error is not allowed. Tell one answer. How one person got 23.6226, other got 23.6193. See, it is not possible. See, you are again, what you are doing, delaying the class by forcing me to calculate. This you should avoid. See, you should avoid this one. Once again I have to calculate now. See, again here light is not proper. 290.7272 into 12.2459. See, it is 2459, not 2549. Print mistake. It is 2459. Okay. See, print mistake here. It is 2459. 2459 plus other force is what? Okay, now it is not your mistake. Okay, I'll agree. Not my mistake also. 4477 into 89.1633. Answer divided by 341.1749 is 23.6193. 23.6193. Who gave the answer? Nandakumar told 21.6993 means he observed the error here. See, 12.2459 by mistake I write 2549. So I made a print mistake and he observed good. Other person, I won't complain because he will tell, sir, you wrote a wrong value. I considered wrong value. Because sometime in the class I will tell, what I write you consider. Okay, done. It is 23.6193 millimeter over. Okay, now we are coming to end of this part, the closing part. So I am going to remove everything now. See, I am going to remove everything now. Nothing required now. Okay, start. All I told you. This is, see, I will tell you once again. This is the bending moment applied, M. This is the internal resisting moment. See, it is in equilibrium. How bending moment is resisted by cross section, I am giving technical explanation. Not simply telling what M by I equal sigma by Y equal D by R. That anybody can tell. Okay, now, lastly, therefore, you can see two parallel forces. One of them is C equal to, where is it C? 341 point, 1766 10 to the power 3 Newton. One more parallel force here, tension force T resultant equal to 341.1749 10 to the power 3 Newton. Make a note, this slight error is because of rounding off error. Okay. Now, there is a distance between them. Lever arm is called A. Lever arm A equal to, see correctly, lever arm A. From the beam, this compression is acting at Y1 bar from here. Tension is acting at Y2 bar from here. Therefore, your lever arm equal to overall depth of beam. Tell how much? I want, this is the lever arm. So, lever arm A equal to overall depth of beam. How much? Tell me. What is the overall depth of beam? First, overall depth of beam. How much? Full depth of beam. First. What is the overall depth of beam? 500 millimeter. So that is total is 500. See, this total is 500. So from 500 subtract which one? Y1 bar, also subtract Y2 bar. You get the lever arm in millimeter. Tell me, first answer. You will get the lever arm in millimeter. Our last answer, because next answer is what? My guaranteed answer, risking my profession. Next answer I told you, my guaranteed answer, risking my reputation and profession. Why? Shall I come after 1 week? Baro, ಒಂದು ವರ್ಷ ಬಿಟ್ಟು ಬರಲ್ಲ. 439 point. Sometime you talk harsh, then answer comes. You talk mildly, no answer. See, it always happens. You talk harsh, answer comes. A equal to 439 point, retry, 6557 millimeter. Now, actually, I cannot write these two values separate. Okay, no problem. Therefore, write internal resisting moment, right, developed by the cross section which is going to resist external bending moment M, that is your M dash equal to, you write either C into A or T into A. Remember, C and T both are equal. Substitute. If you want, substitute that value into this distance, A equal to 439.6557 millimeter, or substitute T value. If you can either substitute C value or T value, you substitute and tell the answer. Tell me the answer in 10 to the power 6. Why? Because force is in Newton, distance in millimeter. You will get Newton millimeter. Answer fast. Answer fast. Fast answer. Over. I told you, if this number is not tallying, so many people will be happy. Why? They will tell, finally KSN made a mistake. See, they will tell, finally KSN made a mistake. They will be very happy. Answer fast. But they will not get that chance. How much? See, first of all, I never bother to check. I know the answer. Fast. 149.99995. 149.99995 Newton millimeter, or 149.99995 kilonewton meter. Over. That is, our external bending moment is how much? Is 150 kilonewton meter. This you can take equal to 150 kilonewton meter. That is same as the bending moment to which cross section is subjected to. Therefore, whatever bending moment you apply for the cross section, it is resisted by internal resisting couple developed due to compression force on one side, one side of neutral axis, tension force on other side, so that tension compression will be equal. The internal resisting couple will be equal to external bending moment. So the principle I told is correct or wrong? Tell me. The principle I told is correct or wrong? What principle I told today is correct or wrong? That's all. I'll go further now. I won't waste time now. The principle told is correct or wrong? You can comment because you are in the class. Why? Is 100% correct. Right. Therefore, luckily, what I risked is no problem. Okay, now somebody may comment, sir, 149.99995 means it is 5 rupee difference in 1, 2, 3, 4, 5. Around 15 lakh rupee transaction, 5 rupee difference. Ayyo, they will tell, agree that way. Okay, now I will go to the important concept. See, 1 minute now. Now, I will tell one thing. So many people, I told earlier that I am asking some brainstorming question. Even recently, one person commented, I told in class number 100, in class number 100, I told you, I am going to ask some brain teasers. Brain teaser means what? Really, which will give full workout for the brain. ಪುಟ್ಟು ಪುಟ್ಟು ಸ್ವಲ್ಪ ಒಂದು 2 ನಿಮಿಷ ಸ್ವಲ್ಪ ಸಣ್ಣ ಮಾತಷ್ಟೇ 2 ನಿಮಿಷ. ಸಿ ಕ್ಲಾಸ್ ನಂಬರ್ 100 I asked. Recently a person commented, where is your brain teasing question? Yes, one of them comes now. Answer this question, then in future ask me anything more. Answer this question, then you next time ask me, where is brain teasers? Brain teasers are there, plenty are there. You first answer this question. If you really answer, I will appreciate. See, if you really answer, I will appreciate. See, come to RCC. Working stress method. Why? Limit state method is beyond elastic limit. There also you get compression tension. See, this I will not write too much now. I write briefly. Imagine sagging BM. This is called width of beam B. Somewhere here is neutral axis. This depth is called X. Here tension steel is there of area AST. And tension side concrete is completely ignored. Now, to locate neutral axis, we equate, you write here, we equate moment of the compression area about neutral axis equal to moment of tension area about neutral axis. Yes, that is nothing but once again y bar equal to A1 y1 A2 y2 divided by A1 plus A2. Done. The equation you are getting is bx square by 2. You may change the symbol, equal to m times AST into d minus x. See, what is m all I won't discuss here. Yes, this is by equating moment of the compression area to equal to moment of the equivalent tension area. Okay, done. That is nothing but locating y bar for our problem. Clear? It is same as locating y bar like what? A1 y1 plus A2 y2 divided by A1 plus A2. Clear or not? Fast. Clear? Tell me, clear or not? Okay. It is clear. Now, second one. See, we want expression for internal resisting moment. That is called later moment of resistance if you consider the full capacity. So, internal resisting moment, say m dash equal to m. Bm is the external bending moment. Now, RCC further I will not explain. See, this is the stress diagram. This is, I take FC. It is not sigma CBC. So many people take sigma CBC. Wrong. It is not sigma CBC. It is the stress developed in concrete. This is FST. FST by M comes. Reason you worry later. Now, therefore, there is a resultant compression force here, C, which will pass to CG, tension force, same level. Okay. FST by M. My symbol, same level tension force T is acting because this is ignored. This is called lever arm A. This distance is x by 3. Then you write M equal to either C into A or T into A. Remember, your C equal to resultant compression force equal to B into X is the area into, I write here, your C equal to B into X is the area into average stress here, FC plus 0 by 2. FC plus 0 by 2, that will be equal to Bx FC by 2. And resultant tension equal to area of the steel AST. Actually, if you want, equivalent area is M times AST into stress there is FST by M, or it will become AST into FST. Okay, I am not going for RCC now. I am asking that brainstorming question. I told brain teaser. Somebody told the word brainstorming. Storming or teaser or anything. Now tell the answer. Show your talent. If you think anybody who thinks they know the basic concept, now is the time to give me answer. So far nobody could give answer. Remember, 39 years I am teaching. In the 39 years, not a single person can give the answer. Let me see who is the first to give answer. Okay, now. So M equal to C into A or T into A. Correct. Your lever arm A equal to, see, this is called effective depth D. You should know in RCC. Lever arm A equal to D minus X by 3. Now, C equation is known, T equation is known. Therefore, your M will come. If I use C into A, it will come Bx FC by 2 into D minus X by 3. In limit state, it comes 0.36 into FCK into what? B into XU into 1 into D minus 0.42 XU. Principle same. And if I take M other way, if I take M equal to T into A, it will come AST into FST into D minus X by 3. If you know RCC, you will be knowing these two equations. Tell me. At least if you are not knowing, today remember, I am not going for RCC. I am telling only what? X. What is the analogy? At least tell me. Have you heard of this equation RCC? Tell the answer. Somebody talking with spirit here. Tell fast. I don't want to reduce their spirit. Tell the answer. This is RCC part. Clear or not? First. Now my question comes. For those who think they are knowing too much, let them show me they know too much. First, clear? Okay. Now, my question for them. See, my question, what you call brainstormer, some word used, either brain teaser or brainstorming or tricky or very, very, what? Delicate point. See, simple. Tell me, when I considered this internal resisting moment in the bending stress theory, did I use, sorry, I make question. See, just now I completed example for I section. See correctly. Those who are serious should write everything. When I considered what? When I considered bending for I section, question, did I use moment of inertia or not? Answer. Answer first. Did I use moment of inertia or did I use or consider? Did I use or consider moment of inertia or not? Answer. Not RCC. Little earlier, our bending theory, M by I equal to sigma by Y equal to E by R. Did I use moment of inertia or not? Question. Answer. Fast. Did I use it or not? Moment of inertia. Fast, tell me. M by I equal to sigma. See, I am telling the equation. M by I equal to sigma by y. Therefore, did I use moment of inertia or consider moment of inertia or not? Fast answer. Closing part. Did I use it or not? You are not answering first of all. That moment of inertia term, is it used or not? When I applied the equation M by I equal to sigma by y. Tell me. Did I use it or not? You are not answering. See. You can see there only. See. Voice is no. I wrote not RCC. Oh, this much difficulty. Forget about RCC. Our bending stress chapter. When I considered bending for I section, yesterday, today's problem. Yes. Answer is yes. Moment of inertia considered. Is considered. In the equation M by I equal to sigma by y. Tell me, yes or no? Past. Used. Now, I will not repeat the question again and again. Now my question is, continue question. Now, just now, I write here, just now, I considered RCC theory for bending. See, you can see everything in the board. You can see everything in the board. Everything in board. Of course, this is not the way I teach RCC. If I want to get this equation, I take at least 5 hours for it. I will explain so many principles, but everything you can see in the board. Now question is, did I consider moment of inertia or not? Answer fast. Answer. See, I wrote bx square by 2 etc. See, CG is located there and this equation for MR or resisting moment. Did I consider moment of inertia or not? Answer. Tell me. In the RCC theory, which I told just now, everything is in the board, not M by I, not this one. In the RCC part, answer is no. Correct? Answer is no. Answer is no. Tell me, fully clear or not? Fully clear or not? Answer is no. In the basic bending theory, moment of inertia is considered. In the RC theory here, moment of inertia is not considered. Tell me, full clear means tell yes, clear. Full clear means tell clear. For those who are watching recording, they should know. Those who are live agreed with him. Tell me, fully clear or not? In the basic bending theory, I used moment of inertia. I considered. In the RC theory, I did not consider. You have to only comment one thing now. Is my question clear or not? Clear. Now, I will tell something only for those who want brainstorming questions. I am telling in the RCC, see, you told moment of inertia is not used. Correct? No. It is used. It is used or considered. It is used or considered. It is used or considered. But tell me where it is invisible. It is invisible. कण्णगे कांटा इल्ला, आंखों को दिखता नहीं. Not visible to eyes. It is visible to, see, inner mind. Visible to inner mind. Like I am standing here. I can see my classroom in Bangalore from here. See, I can imagine. Oh, that classroom, benches there, the usual my board, the entrance to the classroom, surrounding place, even though not visible to my eyes, to my inner mind, ಮನಸ್ಸಿಗೆ ಕನ್ನಡದಲ್ಲಿ ಮನಸ್ಸು, ಹಿಂದಿಲಿ ವಾಟ್ ಐ ಕಾಲ್ ಮನಸ್ಸು, ದಿಮಾಕ್, ದಿಮಾಕ್ ಮೇ ದಿಕ್ತಾ ಹೈ. Same way, I am telling, even here, moment of inertia is considered. It is not visible. Now the question is, those people who want to answer, now answer this question. Answer this question. Then only ask further questions. Answer this. You can inquire wherever you want. You can inquire wherever you want. Don't ask me. So therefore, now invisible, now make it visible. Make it visible. Okay, 1 minute now. I will make it visible myself now. See now. See, I will make it visible myself now. See now. 1 minute. See. Yes. Yes. Fully visible. Fully visible. ಕನ್ನಡದಲ್ಲಿ ಗೊತ್ತಾಯ್ತು. ಹಿಂದಿಲಿ ಪತಾ ಚಲ್ಗಯ. English. Yes. Completely clear. Now answer the question and then only ask for more question. Anyway, I will keep on asking such questions. Today is the question, first question I asked. Answer that and then proceed further. Okay. One small information for everybody. Small information for everybody. I am in native place now. It is in South Canara, that is Mangalore, Dakshina Kannada, that is near coastal area. Tomorrow I am going back to Bangalore by daytime. Morning I will leave at around 8 o'clock. I will reach Bangalore by evening 7:30. So tomorrow I will not be able to take the class. So your next class will be, your next class of the BSK, for BSK, that is bending stress continuation, will be on Friday. On Friday. Clear? Friday evening, usual 7:30 p.m. So tomorrow, don't ask when is the class. I will be in journey. If I take the class, I take the class in the bus only. Bus I can't take the class. I can take, but the co-passenger will object. Ivrದೇನ್ರಿ ಗ್ರಾಚಾರ ಅಂತ. So Friday there will be class. Clear now? Next class will be on Friday. Clear? Okay. Thank you. We will meet on Friday. For BSK group, I will give the message for them. Others, those who are general public, I am telling now. Okay. Thank you.